All right. So, starting off chapter one here, starting to look at patterns and inductive reasoning. So, give an example of a pattern. And actually, let's flip on some lights so we can see a little better. All right. So, patterns can be any sort of repeated grouping, I guess you could say. So, whether that's numbers, so say a pattern of 1, 2, 3, 1, 2, 3. It could be, say, even 3, 6, 9, 12. We have a repeated pattern here. So here it's a group and it repeats. Here we have a pattern of we're increasing by a certain amount each time. It could be a deal where we deal with shapes of, say, triangle, circle, square. Triangle, circle, square. It could be objects. I'm not going to try to draw objects just because I'm not that bad of a drawer, but you kind of get the idea. It's going to be a repeated grouping of things. And really, that's what we're going to use then for inductive reasoning. So inductive reasoning is reasoning that's based off of patterns that you observe. So like looking up here, you can go, oh, well, I see it's going 1, 2, 3, so the next one has to be 1, 2, 3. Oh, I see it going by 3, so the next one has to be 15. We can start making certain reasoning or figuring out what's going to happen based off of what that pattern is, and then be able to come up with a solution. So, like here, find the pattern, and then show the next two terms. So as we look here, we go, well, 3 to 6, 6 to 12, 12 to 24. Well, if I double 3, 3 times 2 gives me 6, 6 times 2 gives me 12, 12 times 2 gives me 24. That's the pattern that's going on, is we're timesing by 2. So the next two terms, well, 24 times 2 would be 48. 48 times 2 would be 96. Well, what's going on here? Well, we have a circle. We have one line through, 2 lines through, 3 lines through. Or you can look at it as we have 2 pieces, 4 pieces, 6 pieces. So we're either adding a line or 2 pieces. A couple of different ways we can look at that one. So we have 1, 2, 3, 4 different lines or 8 pieces. 1, 2, 3, 4, 5 lines or 10 pieces for the next one. Yeah. So figuring out this was times by 2 or adding a line or the 2 pieces is a conjecture, which is just a fancy way of saying, hey, you came up with a conclusion using inductive reasoning. So it's a specific type of conclusion that we deal with. Now, sometimes these problems, it's not quite as easy to find out what the pattern is. So for example, here we have make a conjecture about the sum of the first 30 odd numbers. Well, right off the top of my head, I'm going like, wow, 30 odd numbers, that's a lot of numbers to try to figure out what their sum is. Now, we could go through and go, well, 1 plus 3 plus 5 plus 7, all the way up until we hit the 30th odd number. But that's going to take a little while. So what we're going to do is we're going to start by using a smaller problem first, using just a few numbers, and then we're going to build. So if we just take the first odd number, well, we would get 1. The first 2 odd numbers, 1 plus 3 gives us 4. Well, not quite enough to determine a pattern yet. 1 plus 3 plus 5. Well, now we're up to 9. Again, not quite enough to determine a pattern. Let's do one more here. So 1 plus 3 plus 5 plus 7. So now we're up to 16. So now with 4 numbers, we're starting to go, okay, where's this pattern going? So we're 1 to 4 to 9 to 16. Now at first you're going, well, we're jump of 3, jump of 5, jump of 7. Well, that's not like a regular pattern jump, and it's not, that's all tying it back to the last one. But we want to know that, okay, if we have one number, what is it? If we have 2 of them, if we have 3, if we have 4 of them, what's going on? Wait a minute, if I have 1 of them, this is 1 squared. If I have 2 of them, this is 2 squared. If I have 3 of them, this is 3 squared. If I have 4 of them, 4 squared. So however many terms you're adding up, it's that number squared is the total you get. So if we want to do the first 30, we would square 30, which is 900. So one example of where bigger problem, break it into smaller parts, use those smaller parts to find out what that pattern is, and then we can use it on the big one. Now, not all conjectures are going to be true. To prove a conjecture is true, you have to prove it for all cases. So every single possible case that's out there, you have to show that that is going to work. Nice thing is, though, if you're going to prove it's false, all you need is one counterexample where it's false. So we're going to come up with a counterexample. So a counterexample is just an example of where it doesn't work. So we have the statement here, a number is always greater than its reciprocal. Now you're probably going, well, if I have 4, its reciprocal would be 1/4. So yeah, it's bigger. If I do 10, well, 1/10, yep, still bigger. That kind of sounds like it's true. However, we just need to find one place where it doesn't. What if we go backwards with this? What if I say the initial number is 1/4? Well, when we do its reciprocal, we get 4. So that just caused this to be false because our initial number wasn't bigger than its reciprocal. So, therefore, we just proved it's false. All we do is one time show it's false once, therefore it can't always be true. So if a number is divisible by 5, then we know it's going to be divisible by 10. Well, I know 10 is divisible by 5. It's also divisible by 10, 20, same thing. However, what about, say, 25? I can divide 25 by 5, but I cannot divide it by 10. So, counterexamples. One time is all we got to do is show it's false, and that makes it false. So, a counterexample is just showing one is an example of something that doesn't work. So the price of an overnight shipping, it was $8 in 2000, $9.50 in 2001, and $11 in 2002. Make a conjecture about what the price will be in 2003. Well, let's look at how is it changing each year. Well, we're going from $8 to $9.50 to $11. So that's a change of $1.50 and a change of $1.50. So it's changing $1.50 per year. So if it's $1.50 more than what it was in 2002, we're just 1 year later, then it should be $12.50. And that's it for this lesson. So, if you have any questions, comments, concerns, remember you can always pan me, email me, send me a message on Google Classroom. I'm always here to help. Remember you can always pause the video if you need to write stuff down, if I get to going too fast for your writing. Or you can always rewind it and hear it again and kind of see how that goes. Otherwise, until next time, we'll talk to you later.